Hello, so in this video I will explain to you guys a new method of graphing sine and cosine that I think is more clear to the one that I explained to you in class. So I'll start with the example. Let's say we're trying to graph cosine of 3x. Okay, so the first step would be to find the period based on what we have for b. So here the coefficient in front of x is 3, so b equals 3. And that means t, our period, based on our formula, would just be 2 pi over b, which is 2 pi over 3. So then the next step for this strategy for graphing sine and cosine would be to graph the axes. And then the next step is going to be to draw the tick marks for the period for this function. So what I'm going to do is go one period to the right all the way down, which would be 2 pi over 3. And then I'm going to go one period all the way to the left, negative 2 pi over 3. So I know that this is going to cover 2 periods of my graph, which is what I need for the quiz. And so that's good. Then I'm going to draw my maximum here and my minimum down here. And typically it's very helpful to draw maximum or like a boundary line for the maximum and then a boundary line for the minimum. So the lines at 1 and negative 1. Okay, next thing I'm going to do is to draw tick marks for every quarter period. Okay, so you can calculate 1/4 of t is just going to be pi over 6. And so I'm going to draw tick marks for every pi over 6 on the x-axis. So every period is going to be split into quarters, which means that the first tick mark is pi over 6. Second one is pi over 3. And the third one is pi over 2. 3 pi over 6 is pi over 2. So same on the negative side, negative pi over 6, negative pi over 3, and negative pi over 2. Okay, and then the next step, which I think is the kind of helpful trick for doing this, is to first identify where the peaks are going to be. And so because I know that cosine must have a peak at the y-axis, that's just something you should know. That you should have memorized the shapes of sine, negative sine, cosine, and minus sine. So you know cosine is going to have a peak at the y-axis. And then the idea behind this trick is that every quarter period, it's going to alternate between peak, intersection, dip, intersection, peak. So if there's a peak at the y-axis, then that means at the next quarter period, so pi over 6, you know it's going to intersect. You know that it's going to intersect the x-axis with a negative slope, actually, because it's going downwards, right? And then after the first intersection, there's going to be a dip at the next half period, and then intersection at the 3/4 period for this, right? Because the intersection going upwards must always follow the dip. And then finally, once we return to a full period, we go back to a peak. And then the same is true for the opposite side. It goes from peak to intercept to dip to intercept to peak. So it always follows that order, of course, right? Because you know the shape of the sine wave. And so the final step to complete this graph would just be to connect these points with a smooth line in a wave shape, right? So I just do this, and then I'm done. Okay, that should have crossed out the tick mark. But otherwise, this would be a good graph. Okay, I'll show you guys another example. Let's say we had negative sine pi x. Okay, in this case, b equals pi, which means t equals 2. All right, 2 pi over pi. And so what I'm going to do is do my graph and draw my maximum and my minimum. I'm not going to draw the lines this time, but you know where they would be. And then I'm going to do the same thing. I'm going to go one period to the right and one period to the left. And since I know that the period is 2, this tick mark is going to be 2, and this will be -2. And then I'm going to draw the quarter tick marks, or the quarter period tick marks. And so those are going to happen at, each quarter period is 1/2, right? Because a quarter of 2 is 1/2. So this is going to be 1/2, 1, 3/2, then -1/2, -1, -3/2. And then the next thing I'm going to do is I'm going to use the fact, which I know, that the negative sine function must intersect the y-axis or the origin with a negative slope, right? So that's what I'm going to do. I'm going to draw an intersection with the negative slope down there at the origin. And so because I know that it's crossing through the origin and going downwards, I know that the next point at the next quarter period must be a dip. So I know that at x equals 1/2, I know that my function is going to be at -1. It's going to have a dip. And so that means the next one is going to be an intercept going upwards, and then a peak, and then an intercept going downwards. And the same is true for the other side. So I know that there's going to be a peak here, an intersection here, and then a dip here, then an intersection here, and then to complete my graph, I just connect these points. So this is, I hope, a somewhat easier method for drawing these graphs. Next, let me show you guys an example of how you would do this when you also have vertical transformations, which is a little trickier, but it involves the same ideas. So let's say we had 3 cosine of maybe 4 pi x minus 2. Okay. Okay, so the first step I'm going to do is to find the maximum and the minimum and the average. So the maximum is simply 3 times 1 minus 2, which is 1, and the minimum is 3 times -1 minus 2, which is -5, right? And so that means that the average is -2. You could have also just gotten the average from whatever constant we're adding or subtracting from the end. Okay? And then I'm going to find the period. So b is the coefficient, which is 4 pi. So the period is going to be 2 pi over 4 pi, which is 1/2. Okay, so with these 4 numbers, I'm now ready to draw my graph. And so the first step I'm going to do is going to be drawing the tick marks. Let's do it up here. So here's my x-axis. And first, I'm going to locate my maximum and my minimum. So my maximum is going to be right here at 1. And my minimum is down here somewhere at -5. And then I'm going to draw my average at -2. Okay? And so for these kinds of questions with vertical transformations, it's going to be super important to draw these 3 horizontal lines corresponding to this maximum, minimum, and average. So I'm going to draw a maximum line here, an average line here, and then a minimum line, a lower boundary right here. Okay? And then I'm going to do the same thing as before. On the x-axis, I'm going to do a period on the right side and a period on the left side. And so each period is 1/2, so I know that these are going to be half and -half. And then I'm going to draw tick marks for every quarter period. So a quarter of 1/2 is just 1/8. And so that tells me that this tick mark will be 1/2. Let me draw it above, actually. 1/2, sorry, not 1/2, 1/8, 1/4, and 3/8. This will be -1/8, -1/4, and -3/8. Okay? And then I'm going to do the same thing as before, except now my effective x-axis is actually going to be this new midline, okay? So this is a cosine function, a positive cosine function, and so I know it's going to have a peak at the y-axis. So I know it's going to intersect this point right here, and that's going to be a peak. Well, the idea is that at the next quarter period, it's going to be crossing the middle line, the average line, and going downwards, okay? So at 1/8, at x equals 1/8, it's going to be crossing the average line or the midline and going downwards. And then I know based just on the sequence of how these things go every quarter period, I know that at 1/4 it's going to have a dip, and then at 3/8 it's going to be going upwards through the middle line, and then at 1/2 it's going to have a peak again. And then the reverse happens on the opposite side, an intersection of the midline at -1/8, dip at -1/4, intersection going that way at -3/8, and a peak at -1/2. And so connecting all these dots, I get this graph here. So I hope that this is a helpful strategy for drawing these. And if you have any more, if you want to see more examples worked out, then you can refer to the video of me working through the graphing study guide. But hopefully this is helpful.